going to introduce the all-star lineup of panelists. I'm telling you, when I reach out to people and they tell me yes, it really shocks me. It gets me really excited. And surprisingly, this time I will be moderating the panel. So I have a first row seat to all of this knowledge. So I will one by one introduce the panelists. And as they come to the stage, I would love for you guys to send some love their way. So our first panelist is Delina Ivanova. She's the Associate Director, Data Insights at HelloFresh Canada. Delina has over 10 years of experience across data and analytics, consulting, and strategy, with roles spanning financial services, public sector, and CPG industries. She is currently the Associate Director, Data and Insights at HelloFresh Canada, where she leads a full-service data team, including data engineering, data science, and business intelligence and automation. She is also a data science and machine learning instructor in the professional development programs at the University of Toronto and the University of Waterloo. Please welcome Delina to the stage. All right, great. All the hearts, love to see it. I am going to our next panelist, which I think for this one, it's rockets that Shopify usually likes, so send them some rockets. I have Michelle Ark. She is a staff data engineer at Shopify. Michelle is a staff data engineer at Shopify, focusing on building and supporting tools for batch data transformations. Shipping critical projects at Shopify now for 3.5 years, Michelle began her Shopify journey as a software engineering intern. Please welcome Michelle to the stage. Hello, Michelle. And the next speaker we have is Serena Ma. So Serena is a senior data engineer for 4 years at RBC. She's inspired by embracing the power of parallel computing and providing business insights. One of her achievements at RBC is the completion of a business match entity resolution for business corporation information. She also loves to bake. Let's welcome Serena to the stage. And last but not least, we have Layli Nurian. She's a manager of data and analytics at Amador. Layli is a manager of data analytics at Amador in Toronto with a master's of science in computer science from the University of Western, with extensive experience in data engineering and analytics and experience working in software financial consulting firms. We're excited to have her join us as a panelist. She leads teams of data engineers, data analysts, and designs and implements analytics and data platform projects. Let's welcome Layli to the stage. So I have to say, there's definitely not a luckier person than me to be able to be on a stage with all four of you. And I'm really excited to dive into these questions. Audience, if you have any questions, you can leave them in the question section and I will check them as well. So I wanted to start with an understanding of how you got into data engineering. I already gave a brief bio of where you're at and what you're doing. Did anyone want to take that question first?
I think I'm happy to kick it off, maybe because I've had a bit of an unconventional path, but I would say that probably 10 years ago when I started working, data science and data roles weren't really a thing or an area that people actively sought out. So I would say that it's definitely grown in popularity. And actually my recent introduction to data engineering has been with my role in HelloFresh, where we discovered a need to just have better control over our data, over our infrastructure, and to have better oversight and kind of proper processes in place and infrastructure in place to be able to do more with data. And I think it's really important to be able to scale your data science projects. So it was a bit of a business need from my perspective of how I got into it, but now it's definitely the backbone of our entire operation.
Unsung heroes.
Yes.
Anyone else want to chime in?
I could go to contrast that with a super boring traditional path. So I did an undergraduate in computer science, graduated, I went to do some sort of traditional software engineering internships and sort of felt like I wanted to be more specialized in a subdomain within industry and software. So I went back and did a applied master's also at the University of Toronto and partnered up with Shopify to complete that. And the team that I found a fit in is the team I'm still on, data platform engineering. And it was just this really, really good blend of industry and all of the courses I loved the most in undergrad, like operating systems, distributed systems. Can talk a little bit more about data platform versus data engineering as we go, but it was a bit of an intentional match for me, and I've been really enjoying it since picking it for the last few years.
Love to hear it. Serena?
My story is very similar to Michelle's, so don't get bored when I was telling the story. It's a very natural transitioning for me as well. After graduating from World Computer Science program, I work as a software developer on enterprise wire system. During the rework, my manager got assigned to a new team. We started to build up a Hadoop platform. He also brought me over to the new team, and then my title was changed data engineer afterwards. So I joined data and analytics team, the same team as Angela, at RBC 2 years ago. The team actually served as an analytical hub. So luckily I got a chance to explore data from different sectors from the bank.
Well, I love how your manager brought you with them. I love that storyline.
It's a very natural transitioning.
Laylee, would you like to chime in?
Sure. For me, it was also a very natural transition. So I started working in the area of data and BI around 14 years ago. I started working actually January of 2009. And so everything was kind of like integrated. Like we didn't have data science in a sense that it exists right now. It didn't even exist. And everything is just like one bucket. You would be just a BI person. And you would do anything and everything from data analysis, building the pipelines, do the reporting, and just name it. So I kind of felt back then that I kind of like gravitated more towards like building the pipelines and defining the data processes rather than more being on the reporting side. So as my role proceeded and I changed companies and moved from one company to another, and then with the introduction of the cloud and the big data and all of those good stuff, then I transitioned into managing data engineering teams.
Sounds great. I definitely remember, I haven't seen a business intelligence role posted in a very long time.
No, it doesn't exist anymore.
Yeah, I never thought about how those roles disappeared and they kind of went into streams. So there are different flavors of data engineering, as Michelle alluded to, such as managing data platforms, data infrastructure, or managing security versus managing data pipelines. Can you provide us with some of the differences between them and some of the skills required for these tasks?
Michelle, you want to start?
Yeah, sure. So I think, so I'm in data platform engineering. I don't write any data pipelines or own or maintain any data pipelines. Instead, our team at Shopify, our org is 100 people, fairly big, and we're really building a very tailored set of tools for other data engineers and data scientists to develop pipelines and reports, ingest their data, really apply a lot of those specific kind of business logic to a pipeline. Whereas we build more generalized systems like overall ingestion systems for our MySQL databases on Shopify applications, or telemetry frameworks for emitting events, or a general kind of, if anyone's used dbt, a general batch SQL transformation tool with a lot of extra support that we can offer because we have like 5 engineers kind of building up on it and really standardizing the usage of it. So it's building, I guess, a more opinionated set of toolings from ingestion, transformation, storage, so that everything can happily coexist and like the many hundreds of data scientists can be really effective at their jobs.
Definitely. I love that explanation of it. Delina, did you want to chime in?
Yeah, I think we're on the opposite end where we take more of the traditional view of data engineering, at least in our team at HelloFresh. We have data that lives in so many different places, and there's so many sort of efficiencies that can be found through building proper pipelines. And now that we're kind of scaling our data team and looking to do more with data, especially when it comes to data science and machine learning, we tend to build those traditional pipelines of automating data flows and making sure that data is available and clean and ready for machine learning. And then we also have, our company is global. So we have kind of the platform team that sits in Germany. And so all of us in Canada and in other countries in the different geographies that we operate, each team is kind of responsible for taking care of their own ingestion as well. So if we have external sources, bringing them in, organizing them, building up our own data storage mechanisms and so on. So a bit on the more on the enablement side.
Okay. Anything to add, Serena or Layli, before I move to the next question?
Just a tiny little thing to add. I'm more on the managing the data pipeline side, not really the infrastructure, because I find project-driven are very fascinating. Involve choosing the right tools for each use case. Hope you guys don't get lost when Agile is pulling different graphs or different share zones in HDFS and stuff. But then, yes, a lot of integrations and securities and monitoring and etc. to make sure that all the projects are to the production level.
One thing I like to add that I kind of feel a lot of time is underestimated for the data engineering roles is that it's very important for someone who likes to get into a full-fledged data engineering role, really building the most efficient data pipelines with all the nitty-gritty involved and having everything right down to the T, is to have a good understanding of the business domain and have a good understanding of the data analysis. The segregation of the duties that have come into place in the most recent years basically has created a kind of like a separation for people. Some people only put their focus on a very specific area of the data management or data engineering or data science. Whereas I think it's very important for everyone who gets into this field to try to understand, aside from learning the technical aspects of the work, to try to understand the data. When they understand the data and understand the business domains, then rest of the things become a natural as to like how you want to apply the securities, how you want to clean the data, what needs to go in, what needs to come out of your pipeline, and what reports or I don't know, models you want to build on top of your data. So maybe it's not very relevant to this question, but try to gain an understanding of the data domains.
That's a very important point, especially if you're dealing with like siloed companies where maybe like the data analytics or the data science team isn't communicating well with the data engineering team. There's kind of that break of the business knowledge, like if they're not collaborating together to provide the context. So that's a really important point, and thank you for adding it. Something that came up while we were meeting and prepping for this panel was the different stages as you're expanding as a company through startup, through growth, and established companies and legacy systems. Would you mind expanding on the importance of data engineering at those different points? Perhaps you can provide some context with your work experience or where you're working now.
Yeah, I'm happy to kick this one off because I feel like we at HelloFresh are going through this probably over the last couple of years, where we went from a small German startup to now scaling up in 16 different countries. And I think we can attest to how challenging this is, because when pipelines are initially built and sort of data infrastructure was initially built for our company, it was built with the knowledge at the time, but you start to incur a lot of technical debt as you expand because there are more needs, more views, people get more creative. And as the data teams expand across the geographies, they want different information and different views. And so we're in an interesting place right now where, we're trying to kind of explore what's the right setup and what's the right organizational structure when it comes to data and roles and responsibilities. So everything from kind of centralized data enablement. So when we think about tooling, does that make sense to be all in one central place? But all of the analytics and things like that are spread out across the geographies. And then same with, from a data engineering perspective, should we put that on a central team to build pipelines for people and create the views necessary for machine learning? Or is that something that's more country specific? So it's been really interesting. And I don't think there's necessarily a right answer. I think all companies go through a stage of centralization, decentralization, and then probably kind of coming back. But the biggest challenge, I think, is dealing with old technical debt, because it just requires such a mass amount of effort to clean up. And so I think a lot of companies get to that stage where it just lets it pile and kind of manage it versus fixing it.
Definitely. Serena, did you want to chime in on this one? Because when I think legacy, like, no shade to RBC, I love you, but you've been around a while. So I imagine there's some legacy systems over there. Did you want to chime in about that?
Sure. I think RBC's well-established company with a surprising long history. When I Google how long RBC established, it really surprised me. I'm not going to spoil the answer. So, maturity and stability are where it shines for those legacy systems. They don't easily break. So during my day-to-day work, I can see the growing needs for different kinds of business insights. Those are new, those are evolving. And data engineer can help them to bring them to reality by productionizing those data pipelines. And then just aside on Delina's comment, it was just, we had a long journey, try to bring everything into one place. And then by all means, the parallel computing has its own power because they bring the data over instead of bring the script over. So it's a local compute. That's why it's much more efficient than any other method. But then if you have too much data in one place, that will lose its advantage. You're moving essentially a lot of data over. So that's sort of like a trade-off you might need to think about when you develop the scope of the project. That's just the one comment I can think about as well.
Michelle, you mentioned when we were speaking in our panel talks that Shopify has grown a lot, and that would make me think, I don't want to be wrong because I know there's Shopify people here, that you guys are in some form of like scale. How have you been feeling the data platforms is growing with the growth of the company as well?
Yeah, Shopify has kind of been going through like puberty over the last few years with all its like crazy growth spurts. And so we've scaled definitely in terms of data and organizational scale, just the sheer number of people that are joining the company, especially data scientists. I think something like half the company joined in the last year, and we onboarded 300 people last Monday, something insane like that. So I can speak a little bit to the organizational scale. Maybe before that, just setting the stage with data platforms and how I think they make a lot of sense at like a Shopify scale company where you really just need to standardize on things like privacy and how that data is handled. And there is kind of a need for these blessed paths of making production systems. But I think it's still really important to have a lot of flexibility in like up and coming prototypes so that data scientists or data engineers aren't kind of constrained just to what is legacy battle tested for those prototyping phases. It's important to have systems that can support like spilling over of data scale, for example. In terms of organizational scale, there's a lot of interesting problems that come with that isn't even about data scale. For example, like the thundering herd problem, where at, let's say, 9 o'clock, all the jobs are scheduled to run, or like a disproportionate amount of jobs are scheduled to run. So being able to design a platform that spreads that load across, even little things like randomizing start times, plus or minus, or just rebalancing, that has nothing to do with data scale. It's just like a ton of jobs are kicking off, and maybe a bit to data scale, like just egress, just reading that data is huge. Yeah, the data scale itself, I think there's a lot of just traditional backend principles that go into building like reliable systems. I worked on a tool we have internally called Monorail, which is really a framework to capture events from all sorts of merchants. So anytime someone clicks a button on a Shopify store, we go through the same framework to send an event to our data warehouse. And I think it was like one of the most visited domains in the world when I was working on it a few years ago. And so things just like graceful shutdowns and restartups of those services are really important, because if you even have like a minute or something of downtime between those things, there's a lot of data loss. So been a lot of very interesting problems to deal with as we go through that. I think I spoke on random topics. I'm not sure I like articulated one clear point, but yeah. Let me know if there's a more specific.
So it must be working
specific,
out.
Yeah.
Laylee, did you want to add anything?
Yeah, one thing I want to add is that for data, whoever wants to get into the data engineering field, there's no such a thing as a perfect project or a perfect data engineering pipeline. Be prepared to deal with mess, because that's what we do. We basically clean up the data. We have to go through all the different source systems, being it legacy or growing data sources. It's just the nature of the job, and that's our job to do. We bring the data together, and that's where actually the challenge and the interesting part of the work is. So it's all about design thinking, being able to have that architectural mindset to how am I going to be designing my pipelines, my target data model, and how am I going to create something that is generic enough that's going to be resilient to the changes over time. And this obviously comes with a lot of practice and experience and just going through stuff. But no matter which organization or company you work at, it's going to be just part of the deal, because that's the job of a data engineer, to bring everything together and clean it up.
That actually, I didn't send you all this question, but it came up as we were speaking. I wanted to know if you had to choose a company that started up and came up with their funky frameworks and you have to redesign it for scale, would you choose like that transition, or like the scale transition, or the like established trying to modernize transition? Like, which of the transitions do you think would be, I don't even know, because like I like challenging work, so like I'm not sure which one would excite you versus which one you would feel like is a drag, like that balance of challenge and work.
Established to modernizing sounds like a bit of a drag, because it's like you already support a ton of things that are established and important and can't go down, but we're trying to migrate everything. Migrations aren't usually the most fun, but do let you have opportunities to like profile new tools and make really big decisions on like, should we use this warehouse or engine or whatever it is. That's been really interesting. I've done a few migrations like that, and the most interesting part is really like making the pick of what you're migrating to. Then it's a lot of spreadsheets.
Yeah, I think there's other challenges that come with migrations as well, because there's tons of dependency on the system that's already in place and the ecosystem that's already in place. And I even think of some smaller examples that we have at work. But even if we change as much as the name on a table in a data warehouse, it requires the change of all 50 dashboards that we use a field for, and that's just one country. So imagine all of the other countries that have to make the same change. So, and that's again not even as big of a scale as something complex like a bank that's been around for 150 years. And so I can't. When I was at TD for a while, we had attempted to do a bunch of these migrations as well, and it was always one of the biggest challenges. Like exactly to Michelle's point, how do you maintain something at the same time as migrating, and then how do you plan for all of the dependencies, identify them all, and plan for them to be changed as well.
Yeah, it is super impactful work though, and super rewarding to be on the other end of it. I would say like you really enable a lot more innovation once you are able to modernize. So yeah.
Yes, definitely wear your capes.
Yeah. The caves go on. Generations.
So what's the most challenging part of your role? I'd like to start with Laylee for this one.
Most challenging part of a data engineer role is dealing with legacy system, hodgepodge of data, dirty data, basically trying to figure out the sources of data discovery, and then bringing everything together, because we shouldn't basically, so there is one part which is data movement, where we get the data and we just move it as is to like a staging area. That's easy. But when it becomes the hard part is when you want to model the data, create a data mart, a data warehouse, when the data becomes generalized. So you're getting data from all the different source systems. For example, let's say customer. Customer has many different definitions in many different source systems. And you have to create like a centralized, unique definition for what customer means. So all of these things, like creating a centralized definition of the data and bringing all of the source systems and creating that clean data pipeline that is customizable for the time being and for the future changes, that would be the most challenging part, I think, for the data engineer. And it's probably one of the most interesting parts as well.
Anyone else? Don't all run to the question.
I think one of the challenges that I find is, as more of a broad topic on building good data foundations, I find that if you don't have good data practices, data management and data governance practices, that makes everybody's job harder, who's then the consumer or transformer of data, including data engineers. So for example, when technology teams build tools and systems internally that are not clear on how data is collected, if there's a particular methodology or calculation, you end up having a lot of missing data. And so later on, your data science team might have these great ideas on building something that requires these missing data points. And as a data engineer, you can build the pipelines, but there's nothing you can do about those missing data points. And so I think that that's a really hard challenge on engineering teams, because sometimes if the data management practices aren't there, they're kind of expected to be the fixers of all, and it's difficult to do that when you don't have consistency in how data is created in the first place.
Yeah, that is like the main goal I find of our platform, is to create that consistent foundation and really enforce it in a lot of ways, which sounds really unfun, but enforcing like usage of a certain tool for the ingestion and of a certain like particular pattern if we know that the data source has like late arriving data problems, for example. So that's a core part of data platform engineering. But I think one of the most challenging things for me is really just balancing the design, like the flexibility that our tools give with making a responsible platform that can be used by everyone. I can give a concrete example of something my team is kind of tossing around right now on this like flexibility versus opinionated. We're upgrading like our scheduling capabilities for batch transformations. We had a super simple system where everything runs once a night. We're making a new tool and it just runs everything overnight. So we want to give flexibility to data scientists to run it whenever. And we want to give them the most flexible thing, maybe just a cron schedule string, so they could say whatever they want. They could say, I want to run it at 3 a.m. and then 3:15 and like never again. But that makes it really, really hard for us to monitor and profile. And we need to sort of add more constraints and say, maybe you want to run it every 3 hours or 6 hours, like windows that we know, so that we can, on the back end, figure out when we can schedule those. So again, like the data flow and egress requirements are spread out for everyone. So it's kind of hard because you're saying no a lot to your colleagues, like people internally, and the data engineers and data scientists internally. So that's what I find challenging.
I like that point that you made, because I feel like we're always on that receiving end of no, because our platform team has to manage all of the things, and we totally get it. And it really kind of, it actually forces us to take a really good look at what do we actually need versus what do we think we need. And having those conversations with business partners, I think, unearths a lot, because everybody would like to have data on a live basis every second, but the reality is that we don't make decisions that way. And so it's always a really interesting conversation. And I know our platform teams are always thankful when we say, you know what, this is actually fine as a once a day exercise. We don't need this every 15 minutes.
Yeah. And there are for sure, business cases where that flexibility is justified. And I think it is important to not just say like a hard no, because that's our precedent, and allow for that flexibility and like work together to evolve what we can handle. Not just be like, this is a hard problem to solve, so we never will. Yeah.
Serena, did you want to add?
I guess for me has always been to keep learning and adapting to changes. As the saying goes, the only constant in life is change. Unfortunately. So technology is always advancing, and business requirements are always evolving, and even data patterns can be fluctuate, may cause model drifting, some email that wake you up in the middle of the night. So I feel like it's very important to keep learning and applying to your day-to-day responsibilities.
Definitely. And I loved all the commentary you all gave. And I'm hoping that some of the data analysts and data scientists and data leaders at the event notice that the data engineering team does not want to tell you no all the time. They are working through it. It is part of their role, and they're trying to be more flexible. I really liked how that was added in there. So before I open up the Q&A, I just want to know if you guys each had a last word of advice for those looking in the audience to transition into a data engineering role, or for those who are currently in a data engineering role and maybe feeling discouraged. Give me your 30-second motivational advice.
I can go first. I'd say keep on learning, stay open to growth, be coachable, and understand the data, learn the technology, and think about design learning and architectural concepts.
Yeah. To echo some of that, I read a really nice quote recently that was saying, what often looks like success is often just patience. I think it's a similar thing. There is a lot of like deep holes to go into in this space, and to really just like persevere through that. It's not really going to be an overnight thing. Yeah. One other thing, if I can steal another 10 seconds, is for me, what's been really valuable is just to muster up the courage to talk to people that I just find really inspiring as technical leaders, and just spend time with them. Whether it's for me, it's been a Shopify. I've found a really good network there, and whatever they recommend to you, like watch that talk or read the book or the blog post or check out that tool that they mentioned. Like actually do it and follow up. And I think people are very receptive to sponges. To what Layla said, just like be coachable.
Yeah, I love that advice, and I think something that I would suggest, and especially with HelloFresh, Alex from my team is here. He leads our data engineering team, and for both of us, I think it's been such a learning experience over the last 6 months or so that we've been running this function, but just not being afraid to ask questions. Sometimes, earlier somebody had asked about imposter syndrome, and I definitely feel that sometimes, where I'm thinking to myself like, oh, maybe I should know this already, or I shouldn't ask. But sometimes I realize just how there's lots of people that don't know things, and there's lots of people that are experts in certain areas or certain parts of the data engineering sphere, and it's okay to ask questions, and most people are pretty open to kind of help me understand what's happening and why. And I would say Alex actually has been somebody who's given me a lot of courage to not be afraid to ask those questions, because again, it's kind of new to both of us, and he has a much stronger software engineering background than I do. But it's been really fun to learn, and what I've mostly been impressed is just the community's openness to sharing and giving guidance, and everyone's kind of on the same mission of making data accessible. So it's been great for us.
Serena.
I guess my advice is fairly practical. You probably can participate in conferences or summits like this one to learn and make connections in the big data fields. And also you can take some online courses or participate in a coding competition, Kaggle and others, to gain some hands-on experience to get you started or have a taste of it.
Great. All great advice. I hope everyone's writing notes because I wasn't able to write down the notes. So I would like your notes. So whoever wants to share them with me, you know where to find me. You can find me on LinkedIn. So we do have some questions. And honestly, if they don't start flowing in, everyone, I'm going to start asking my own. And I'm sure you don't want that. So
we love your questions.
Very much. I really appreciate it, especially when I was working like in a corporate environment. Like data engineering was like the one thing that was so hard for me to learn. So I'm actually really honored to be here moderating this panel and running this event. So I do have a question here. So can you each name one super important tool / skill you think one should have to land an entry-level job in data science field? I'm going to reword it to data engineering because we are at a data engineering event. So what is one skill that you think would make you look more solid on your resume for a data engineering role?
SQL for sure. For data, if you're just entering the field, it's a must-have.
Yeah, SQL for sure. SQL definitely. And then learn also PySpark or Python, especially if you're getting into big data.
Yeah.
If really we're talking about the most important ones, those are the two. I'm not going to throw more into that. Like, yeah, I agree.
I can't let you guys all say SQL. Like, that's not what I'm here for. I'm the moderator. I can't.
But then there'll be 4 super important tools.
Okay, data design, data modeling.
Yeah,
that's important. That's very important. Data modeling, SQL, Spark, Python. Go for it.
Okay. Michelle, Serena, anything to add, or did Laylee take it all?
Yeah, she did. Literally cannot add anything.
Okay, great. See, it's not easy. There's a short list of skills you definitely need on that entry level resume.
Yeah. In terms of like maybe not resume, but just skills to have, entry level, technical writing and like version control, GitHub. I think most entry level people really just struggle with getting a hang of GitHub, and that's where a lot of collaboration happens. So if that's already super solid, you'll literally be months ahead when you start.
With an extra tip. The next question I have is from Zoha. So how essential is an individual's foundation in statistics for aspiring data engineers? As you see, I'm ignoring the data scientist piece. Who'd like to tackle this one? I know me and statistics had a really interesting relationship in university.
It's not relevant for data engineering. Sorry, go ahead.
Yeah,
It's not relevant for data engineering statistics, but it is for data science.
Yeah, I think it depends on the level of scope too, and the company you're working for. Like I definitely don't think it's really relevant for data engineers either. But Alex, again, I'll reference Alex, who's leading our data engineering team, and he has a data science background, and I'm sure he can comment more than I can. But I'm sure it helps him a lot, especially on being able to define the business problem. And when we're thinking about modeling and building models, it's certainly helpful to understand how they work so that you can, as a business, as a partner, provide guidance on proper structures or any data transformations that need to take place as part of the pipeline. But at an entry level, I would say it certainly is not required.
Yeah, I'd agree. In data platform, I don't think it's necessary. Like, I can attest to that. There are a few specific tools and types of tools that it's really an asset if you have it for data engineering, like for platform as well. We have a team that builds like our experimentation frameworks and pipelines, and to build those, they do need to understand how to properly run an experiment with statistical significance. So that team was actually a team of data scientists that got together, and now they're in platform. So I think maybe for certain types of platform work, it's extra, it's an asset, but not required.
Well, my comment is a nice to have. I mean, statistics is very essential for modeling, And then for data engineer who work very closely with the data scientists to understand and productionize the pipeline, that's a very nice to have, but then it's not required at all. Like it's a very nice to have, but not very required as an entry level.
All great answers. So it's looking like if statistics is not your thing, you could probably get away with not doing it. The next question that I have is from Alex. What data engineering tools do you think will pass the test of time? And more interestingly, which ones will not? I like this one.
Asking us the tough ones.
I think that for the tools, so there are some out-of-the-box tools that are being used for data movements and data, some very generic data transformations. I'd say learn the basics. Then you're not thinking about the tools anymore. Tools come and go. Technology changes over time. The concept doesn't change. So if you learn the concept, no matter if it's big data, legacy, on-prem, it doesn't matter because you understand the concept and you can apply the concept.
Yeah, tool specific, and I completely agree with that. I think SQL will probably stand the test of time as much as we'd like to work with unstructured data and not use structured data. I don't think that that's going away anytime soon. But yeah, and like even we're starting to notice changes in even programming language of choice, like Python. Now there's different options of different languages that people use, and it's kind of I know Go, I think, is the most recent one that I heard that our data engineers use or platform engineers use in Berlin, and so we're starting to see things that are shifting based on the complexity of data systems.
I've been working primarily with batch systems for the past couple of years, but I feel like they're really solid arguments as well for streaming, growing more and more in use cases and taking some of batch use cases away as well. I'm curious to see if it'll stand, the test of time. A specific one around SQL is dbt, which is what my team uses. I wouldn't bet against relational. So I think that'll stand as well. Which ones will not? I'm asking this, but I haven't thought about it yet. I think maybe right now I'm seeing a lot of new tools around like data cataloging, and there's just a lot of competition around like visualization tooling and stuff. Maybe that just feels a bit saturated, and we'll get towards a more standard tool there. But it feels like there hasn't really settled on a leader.
I think what's kind of interesting to consider on this one too is out of the box versus customizable tools, because I feel like we all went through a phase of customization and then we went through a phase of out of the box, but now that we have better tools that can build pipelines a bit easier, we're probably moving back towards more customizable tools. So even like some of the things we're talking about at work, like how do we move away from Tableau and start building web applications, which are now there's providers that make it really easy to build web applications. And now you can really customize what your dashboard looks like instead of being boxed into the capabilities of Tableau. So it's really interesting.
Yeah. Another lens that came to mind when you mentioned that was around like open source tooling and communities, and the open source tools that have like real backers, whether an industry, like a big company sponsoring them, or just have a really, really great community. I would bet on those sticking around as well. It's unfortunate how often you see sometimes like a really good tool, but maybe the community falls apart and it just becomes legacy and no one can use it anymore. So yeah, that might be an interesting way to indicate where things are going.
It is indeed a very tricky question. The first time I saw it, I was like, oh, only the time can tell. It's like, it's hard to predict everything that's going to happen in the future. But then on the other side, logically speaking, it would another angle to look at it is the cost to replace it. You could also watch the trend, attending conferences or some successful stories, how they implement certain systems to see or to detect the industry trend, to see which one is harder to replace the tools. So that's one would pass the test of time, I guess. But then not just one tool, no tool can pass exist from the day one to right now. So it's sooner gonna pass. It's just a matter of time when.
Those are the predictions from the panelists. Our next question is, what is your opinion on learning data engineering in context of cloud platforms? For example, Azure's data engineering certification.
Maybe I can talk to this because I work at Amador, which is a joint venture of Microsoft and Accenture. The certificates are great, and there are multiple benefits on getting certificates. Looks good on resume, shows that you have basically at least learned about the area that you're applying for the job. But don't think certificates on their own would be sufficient. Always do your own projects on the side to apply your learning on a real case, real world scenario. So define a project for yourself and apply those learnings. But Azure is definitely a lot of the companies which were previously Microsoft shops have been transferred to be Azure Cloud right now. And especially in Canada, Azure is very big. After Azure would be AWS, and probably for some other companies, GCP. But they're all good. I think Azure would be more natural for a lot of people who come from a Microsoft background.
Yeah, and I think from at work, at least for us, we are on an AWS platform. And for us, I think there's a bit of a difference between Azure and AWS, but I would say it is very valuable. AWS has, I think, over 500 different services, and it's kind of impossible to just learn them by trying. And so going through the certification process is helpful because it teaches you how they work, how they integrate with each other, and how to use the tools effectively rather than just kind of building things blindly, because obviously it can cost a lot of money. But any of the certifications I think would be great.
Anything to add, Michelle or Serena? Because something came up to my head, so I'm ready. I wanted to know if those certifications for those who are hiring managers on the panel, do they mean anything to you? Do you look at the resumes and see those certifications like, yeah, like, does it? No. All right.
I value them. For us, we value them because AWS is really complicated, and it's a much more hands-off than Azure. Azure, I think, is a bit more hands-on. And to be honest, some of those developer certifications, they're pretty difficult to get. They're not something that you can just get. And having the familiarity of the ecosystem and how to optimize the AWS services is important, because otherwise you can rack up thousands and thousands of dollars if you don't know how to use it well. So for us, I think we do value them.
I think for me, it's more about the experience. If someone knows how to do something, for people who maybe don't have enough experience, it's very important to have certificate, because you always have to show something. You either show your experience or you show your certificates. So, but I agree with Delina. Like, there are some specific topics that are very configuration based. So you have to really study it, and you really need to know it. But overall, I think if someone has the experience in working in an area, getting certificates is always nice to have, but it's not necessary. But if you're getting into some area, it's always good. And it's for someone who is trying to get a role, it's always helpful to do whatever they can to just boost up your profile.
Good answer. So we're not throwing away the certificates. Good to hear. The last question that I have here is, how should one practice for the big data tools to enter the data engineering field?
get a free AWS account or get a student account, get a free Azure account. And one thing I really like Laylee's point on doing your own projects. The thing I love about data roles in general is data's everywhere. So even if it's a matter of scrape a website, build a pipeline, demonstrate that you can pull data from some source somewhere and just build a pipeline and build a little application for yourself. And it's a really good practice to start using like a cloud platform, or to just practice what the flow would be like, or to even just think through like, how would I get data? How does it need to be stored? Where would it live? How would it be used in an application? That would be my 2 cents advice.
Serena?
Mine was to take, I might have mentioned that before, is to take some competitions from Kaggers or other projects that require you to have a certain level of coding skills, and then probably scraping from where they provided some data. And then you can use some open source data pipeline modules from Databricks from Apache, trying to leverage them and then pull it all together to finish a computation that will give you some sort of accomplishments during that process. And then also it shows you really have the interest in the data engineering field. This is something you look forward to do for at least a short while in your career. That would be my advice.
Anything to add, Laylee or Michelle?
I think those really covered it.
Yeah, no, yeah. They covered it. Just do your own projects. There are a ton of like free learning platforms right now. Just go on one, start learning Python, SQL, GitHub. Just do it.
Yeah, get your hands dirty.
I did have one more question asking if projects outweigh the certifications and look more appealing to recruiters.
Any sort of, I think, practical experience is always valuable. And again, to Laylee's point earlier, like I think certifications are an excellent demonstration of your understanding, especially the complex certifications like the developer certifications. But yeah, like anytime you can demonstrate that you've added value to yourself, or you've done something that does something, then that's always better because it shows an application, right? And your ability to apply concepts to a real problem.
Okay, great. I feel like they're all in consensus with each other. So as I usher these panelists off the stage, I would like to give them a big thank you for basically spending dinner time with us to talk about data engineering, to talk about how their capes fly in the wind, and all the great work that they're doing and how to join the field. So I would like all the hearts as they slowly get ushered off the stage. Michelle, Laylee, Delina, and Serena, thank you so much for joining me tonight.
Thank you.
Thanks for having us.
Thank you. Yeah.